Hello, everybody. Thank you so much for joining us today. We are going to be talking about best practices for indoor mobile mapping. We've got an awesome case study here with PrecisionPoint using the NavVis scanners, and really looking forward to this one. So we're going to go ahead and get rolling here since we've got a good crew online already, and do a little housekeeping first, though, just so everybody kind of knows what's going on. So if you go and hit to that next slide, James. The couple of key points here, everybody is muted, so we're not going to be able to hear you if you talk, but please ask questions via the chat during the session. There's a little questions area. You guys can go plug in your questions. When we get to the end of Q&A, then I will be going through those questions and asking them of our presenter. And we've got some backup as well from NavVis if there's any questions about the equipment. So Merrick will be here to answer some of those too. We are recording the webinar, so no stress if you have to drop out early. If your kid runs in on you and there's an emergency, that happens during COVID, so don't worry, we are recording. We'll be happy to, we'll be sending it out to everybody actually that registered. So that'll come out in about 2 weeks, and just watch your email if that's the case. You'll see the invite to that video when it launches. And with that, let's do some quick introductions here. So we have got with us today James Wott, project manager at PrecisionPoint, and I get barking today. Excellent. So first realistic COVID webinar moment of the week. So James, why don't you do a quick introduction?
Yeah, hi everybody. Thanks, Kelly. Appreciate you having us today. Been here working with PrecisionPoint for a little while now. Been in the industry for a couple of years, and really came from an engineering background, operations and scanning. So a lot of scanning experience in the field, and I'm excited to share this case study with everyone today. And fun fact, if Kelly, if you ever want to talk about laser scanning at 6 a.m., feel free to call. I will be wide awake due to the cats jumping on me for their breakfast. So happy to take your early phone calls.
This is why I have dogs instead of cats now, James, because I do not like waking up early, and my dog is perfectly happy to sleep till 10 a.m. So I've chosen well, apparently. Awesome. Glad to have you with us, James. I am Kelly. I obviously with ClearEdge 3D am responsible for our industry strategy. Do a lot of work with the US IBD, spent a lot of time in the industry on the BIM VDC side before joining ClearEdge. If you don't know me, you'll learn that I play guitar moderately well. We'll leave the I don't know who put poorly here. I'm kind of offended, Paula. I think you jumped in and changed the slides just to throw me off. It's a good play. Yeah, with that, James, why don't you take it away? Let's take a look at this awesome project that you guys have done.
Yeah, so this is a relatively simple project in terms of laser scanning practice, and I wanted to share it though because it was a great example of how we combined several tools and took advantage of the wall extraction in particular with the ClearEdge software. So this was actually a large 100,000 square foot space that we scanned. Actually, it was larger than that, but we only scanned 100,000 square feet, and really just a typical office space, with a cube farm. And this space is going to be renovated for some new office and research facilities. So they did not have up-to-date as-built drawings on, both the architectural layout as well as the MEP. So ultimately, the customer was delivered point clouds, the indoor viewer as part of the NavIS deliverable with the mobile scanning, an LOD 200 model. And throughout the project, we were able to deliver pieces as we went along, and I'll talk a little bit about how this project was divided into a few areas just to simplify coordination, communication, and file size management. So the customer wanted to capture this space, and you can see on the right just a portion of it. All of those gray dots representing photographs that were taken by the mobile system. The customer wanted this space captured very quickly because the overall project, or our scope of work, had a 8-week timeline for all deliverables to be processed and generated. Something very typical in laser scanning, we look at a lot of these projects through maybe like a basic egress plan or some type of old as-built to get a sense of the layout of the space and the square footage. And of course, this is no different. The walls and way that the space was chopped up was, of course, different than we anticipated. It's a little bit of the expect the unexpected, right? So you think that you're going to have some wide open areas just filled with cubicles and that's it. And as it turns out, a lot of these areas have some partitions that were installed, areas broken up. So it just changes a little bit of your plan when you get there. And of course, just navigating, getting yourself oriented. I was out on site a few times, and I know the very first day, everything looks the same. It's just rows and rows of cubicles, and it's easy to get lost. So that's just one of the things that comes with scanning a lot of times. Let me know, Kelly, if there are some questions that pop up as we go along here.
Yeah, will do.
And of course, I mentioned the layout, and of course the piping was another piece of this project, because being an office building, we expected some pretty basic fire suppression and typical utilities overhead. But one thing that changed the dynamic a little bit was just that this building had been through several renovations. So when you're talking about 100,000 square foot area, and we would start in one area, pop the ceiling tiles, take a look around, determine yes, this is a good spot to take a scan, or no, there's some HVAC totally obstructing your view, so we'll move down to a separate area. And we can usually start to predict how quickly we're going to finish the tripod scanning on site. And unfortunately, though, when we got into some of the other areas, we had some different configurations just due to some of the renovations that had taken place over the years.
So you're saying the site conditions weren't exactly what was expected or showed up in the drawings that you bid on, James? That never happens, right?
Yeah, never happens. I've learned maybe the hard way to, like I said, expect the unexpected at many laser scanning sites. And oftentimes, the client may have not been on site either. So, that's part of the challenge, and part of the reason they're scanning, quite frankly. So I'll talk a little bit about the project in particular, just to kind of frame up our approach here. So initially, this project scope kind of changed a few times as we were looking at it in these different areas you see outlined here, and eventually it was decided that yes, they needed the whole gamut, the architectural, the MEP. So we opted to do a hybrid approach on this project, in which we would scan the above ceiling space with terrestrial scanners, essentially traditional methods, and then utilize our M6 scanner, our mobile system, to take care of the entire architectural space, getting some of those extra details in rooms and things that when we're focused on above ceiling, we're really not concerned about those other items. It allows our crews to just focus on the task at hand, and gives us a chance to use some of the other tools associated with the NavIS system. So what you see here is just the basic. This is essentially the scope that I was given during the bid phase, and you'll see all these different colored areas marked, and the customer had these areas already laid out. So from our perspective, we said, well, let's just use the same naming conventions and kind of break these areas down as we track our field notes, and just track our day-to-day progress. So throughout this project, we decided, we're going to start with the tripod scanning. That's going to be the bulk of the time, and we'll use that to set up a coordinate system that we can then use as SLAM anchors to tie the mobile data to. So we had several hundred scans that were taken because we were extremely thorough with these above ceiling scans. And we were out there for about 20 days, most of the time with just one technician operating 2 machines. And during that time as well, kind of making their plan for that mobile capture. We of course had to lay out those SLAM points ahead of time, which in this case we simply utilized adhesive checkerboard targets. And so we picked those up during the tripod scans. And then when we got to the point where we had all of that at least laid out, we were able to bring an additional technician out while we continued on the tripod capture and start running the mobile system.
Real quick about, you may be hitting it right here, but in addition to the scanning time, about how much time did you guys spend post-processing, getting all that data ready to model with?
Yeah, that's a great question, and one of the key takeaways today has to do with kind of my focus on reducing labor hours, right, on these different tasks. So of course the tripod scanning is fairly time intensive. Of course we can mitigate that running 2 machines, and then of course some back office processing. So our office processing on the tripod side is about 20 to 30% of the site time. We estimated that if we were only focused on architectural capture, and I'm only talking about the scanning at this point, we would have spent, and I break this out a little later, but we would have spent approximately 80 labor hours total associated with that. And so with the mobile system, we actually spent more time, I think, talking about what we were going to do than actually doing it. So 1 technician, 8 hours on site, was able to mobile map this entire site, which was just over 100,000 square feet.
Yeah, it's one of the things that I've heard before from people is that because I think people are less familiar with mobile scanning methodologies and techniques, that it's really important to do a lot of planning for it, so that you get the best results. And whereas people I think are just used to terrestrial scanning, and once you've done a couple 20, 30 projects, you can kind of plan on the fly almost. But with the mobile scanning, that the project planning is crucial to getting good results. And but it's easy to spend that extra day doing planning because the capture is so quick.
Yeah, I definitely agree, and I think the other advantage to completing the tripod piece first, and we could have done it either way, but because we hadn't seen the site before, it gave our crews the chance to maybe kind of change their game plan based on what they saw on site. Hey, we'll do this a little different. We'll lay this out a little bit better, and then when we complete the mobile capture, it'll just go that much smoother and that much quicker. So definitely some advantages there. Additionally, and I'll actually share just a brief preview of the indoor viewer on this site, which is an especially useful tool while people are working from home or unable to visit sites, either because of the pandemic situation that we're in currently, or simply because it's far away and you want to manage your project budgets and save some money, so you can take advantage of these tools. So here you can see I've already logged in. You would have a username and password. You can password protect the indoor viewer, and then just take a simple virtual walkthrough around the site. It's very very easy to use, very intuitive, and you can just navigate around the site. And these are the key maps that I shared earlier that you were able to see in the slides in the beginning. So you can see those, how many pictures we took on site in addition to that data capture. This is a great collaboration tool. You can take notes, you can share the URL based on just where you're at to get somebody to zone in on a location. And just for some context here, you can see that adhesive target that we placed, and we just had that right in the path. And you'll see here there were several. When I showed my pictures here, you could see kind of the path that we took. So it was hit multiple times by that mobile system. Jump back in here. So, the indoor viewer was one of those tools that we were able to deliver to the customer, and they could start getting familiarized with the site, because many of the people working on the project, like us, hadn't visited the site or weren't familiar with it. So data capture, we talked about. Fast forward to completing that and getting into the stage of now we're going to start processing these files, some of which we began doing after tripod capture was completed. And now we're looking at this massive area to model, and we think, well, gee, the architectural ought to be faster. We should be able to get that done much quicker. So let's go ahead and we'll run these files through the Edgewise software by ClearEdge, and get these walls extracted. So now we're able to do some hands-off processing where we can bring in that point cloud file that we've captured, that unstructured PTS from the M6, and just walk away from that system while that runs. And based on the areas we had broken the site into, the automated portion was anywhere from 30 minutes to an hour, and I think we ended up with about 8 to 10 different kind of breakouts that we did, because some of the areas we cut in half. And the beauty is that we could do that, let that run overnight when people are not in the office, so that we could leverage our resources most efficiently, our licenses, and just take advantage of that computing power in the off hours. Now, once that auto extraction piece, which we also use for the piping, but once that is complete, we do some cleanup with the walls, and I've got some videos here at the bottom. You can see a few things, like a door that was open and a couple of scans was picked up as a wall, and just some connections that need to be made. We're filling in some of these areas here. This is super simple to use. If I can do it, then I think anybody can. And it's a great way to help with this project load by having some other folks help out with this extraction. See, we had some, it looks like my chat windows flashing. Did we have any questions there, Kelly?
I was gonna take them at the end, but yeah, we got a bunch of questions coming in, but we can save most of them for Q&A.
Very good. I'll keep going. This is just kind of a preview of the tool. I've got another good one here. Kind of shows it a little bit cleaner with the points turned off, so you can see this is, again, just one small segment. This took about 30 minutes to auto extract, and you'll see here, I believe I turned the points off. So now you can see, all those areas. You can go in and connect these walls, clean up, either remove walls that shouldn't be there, or add some that were, maybe missed in the auto extraction. The beauty of this, and the one thing I was really impressed by, especially in this environment, was that none of the cubicle walls, from what I had seen in the auto extraction, were detected as walls. So that was pretty impressive to me, because I would have anticipated that to have been, one of the things that would have gotten pulled out of this auto extraction.
Our algorithms get cleverer every year. A little bit at a time, man. A little bit at a time.
Yeah, no, it's been awesome, speeding that process up. So I talked about, delivering this model in phases, allowing the customer to get started sooner, and a little bit on the capture side as well. The mobile system truly saved us, a ton of hours. We estimate approximately 10 days in the field, given, just the size of the space. Again, this was captured in 8 hours with the mobile system. And the other thing that I really like about the mobile technology here is we can use that as an opportunity to just focus on getting those extra photographs that, you know, help the users that may not be as familiar with point clouds, using that indoor viewer platform, and you know, getting additional point coverage on walls. That's going to make all of those things easier to identify. And then we're going to really be able to take advantage of using all the tools at our disposal, including the edgewise extraction. As far as the modeling time, as opposed to, you know, manually, what I'll call a manual extraction, going in Revit and doing some tracing of the point cloud, if you will, we estimated that we would have saved approximately 3 weeks of labor time by taking advantage of, you know, leveraging the hands-off auto extraction for, you know, for one, and then also just, you know, doing that wall and that pipe cleanup, being able to keep, you know, lots of folks productive and contributing to the success of this project.
And it's kind of an interesting thing, because with the mobile scanners, you know, the data doesn't look as crisp or, you know, as clean as a terrestrial scanner, just in terms of the localized noise in the data, right? But yeah, as you mentioned, you get much better coverage because you don't have all these shadows. But it's kind of an interesting thing where I think most people that have modeled from a point cloud in a tool like Revit, you know, getting the wall drawn doesn't take much time, but making sure that it's accurate enough, but not too accurate, you know, that's where you burn a lot of time. And the same thing goes with piping systems, right? You know, you draw the pipe in and it's flat, and then you have to go and tweak it and lift one side and get the slope. Then you have to, you know, adjust the endpoints and make all the fittings and connections. And it's that kind of work of getting the model to the LOD that's required, to the kind of accuracy that's required, but doing it carefully so that you're still kind of operating within the, you know, the expected tolerances of the software that you're using. That you spend a lot of time doing that work if you're doing all this stuff manually, and it's a very different process, right? Using these kind of automation tools, because they'll put it in, you know, accurately with, you know, however abstractly you want it to be, but they'll get it in accurately from the get-go. But then there's other steps that you end up doing, trimming walls, things like that, you know, you wouldn't have done if you were drawing manually. But it's always neat to see kind of the comparison of the two workflows. But it's just two very different types of two different ways to model.
Yeah, definitely different strategies, you know, for sure. And again, you know, Kelly mentioned this earlier, just with that, you know, that planning element, which is really important regardless of, you know, the tools you're going to use. But it helps for everyone to understand, you know, what direction we're going to take on the project. Yes, we're going to use, you know, some automated extraction tools. So, you know, let's bear that in mind, you know, as we handle our coverage. You know, we want to use the tool successfully, but we don't want it to necessarily replace, you know, people thinking and making, you know, sound decisions as they move through a space.
Oh.
And here you can see, and we talked about this, but the breakdown of you know, the time savings. And again, I can't stress this enough. Not just on the capture side, but also on the modeling side. You know, when you're eliminating labor hours with some hands-off time, you're just leveraging your resources so much more effectively. We can be more efficient. We're able to share that efficiency with our clients, not only in, price, but just at the speed at which they may receive either final or progress deliverables. So it's really just about using every tool as effectively as possible, and keeping the project on track.
Fantastic. And actually, I have a question that came in that's related to this. Obviously, you have the terrestrial scans and the mobile scans. How did you guys register those together? Were they geo-referenced? What's targets? What software did you use? What was that stitching, that you guys ended up doing? What was that work?
So I appreciate that. I'll share a little more detail. So we were utilizing Faro X and S series for the tripod capture, and we registered that data through traditional methods using Scene software, putting those scans together, validating quality registrations, with typical workflow, utilizing spheres to tie those scans together. And then those checkerboards that I showed earlier, and we've got a picture here. We used those as the anchor points, if you will, to tie that mobile data to the tripod data. And so the image in the bottom right, you can see I've made some little yellow circles on all those different adhesives that were laid out in this one particular area. And we just pick up that checkerboard in the tripod scan. It has a X, Y, and Z value that we can then export from Faro Scene. And we do that for all of the checkerboards that we will capture with the mobile system. The mobile system has basically a laser plummet that we center over that target and capture that specific point as we move throughout the site. And then on the back end, we take the coordinate file from Faro Scene, and we export that as a TXT, a text file. And then we just apply that to the mobile system as a SLAM-based registration. Now, this actually helps us in two ways, because not only were we able to tie the tripod data successfully, but because we had multiple data sets, it also reduced and really almost eliminated any of the manual registration associated with moving data sets, around from the mobile system. So again, we were able to use that to gain some efficiencies as well. And just sort of some, I would call these tips and best practices, and these could be good questions that architects and engineers may ask their laser scanning provider, things to think about. Is having a color scan important to them? Of course, with the above ceiling, you're not going to typically have very good lighting conditions, so color may not be an option in those cases. But in some of these other areas, with the mobile system, it's especially useful to have those color photographs. It really helps people just wrap their head around the site, makes it more as if they're there, in real life, so to speak. So just a simple question to understand that, as well as what are the accuracy needs? What are the elements that the customer wants to model? In this case, an LOD 200 model is fairly basic. So, that being said, if the customer wanted to utilize the photography to look at sprinkler head locations or light locations for the purposes of some demo plans, they could take advantage of that. But they may not necessarily need, built-in casework modeled. So those are important things to share with, your scanning provider.
Definitely.
Yeah, and just think about, how you want to align the data up front. In this case, because the customer didn't have anything proposed that was developed yet, they didn't have any existing CAD files. It wasn't necessary to align it to a model, but we wanted to give them something, that was usable. So we used that coordinate system, and then that data was then oriented, as you see on the indoor viewer, to the general orientation of the building.
Awesome. Well, do we want to go ahead and move into Q&A? I'll take that as a yes. You read my mind. It's amazing. Fantastic. Well, we do have a number of questions pulled up here, so let me start blowing through these. And just a quick reminder, if you joined us a few minutes late, the whole thing is recorded, and we do send it out at the end. Well, we send it out about a week or two after, so we have time to clean up any weird audio stuff that may have happened, like my dog barking at the beginning. Yeah, with that, let's get on to the questions. So let's see, we got a question about whether the project was multi-level, and so did you guys end up spanning multiple levels on this one, James?
So this was just a one-story building.
Gotcha. But if it was multiple levels, how would you have tied the floors together? Would it be through total stations, setting up those controls, control on different floors, static scanning slam anchors? What would you guys have done for that?
So in this particular case, because we were using, what I'll kind of call that simulated slam, since we weren't shooting it with a total station, I would have carried that practice through in the same way. I would have occupied some upstairs points, with those checkerboards, tied that in with the scanner, and just treated it, the same way I treated things on the first floor, but really leveraging those hard points, if you will, those checkerboards to tie the separate floors together. In this case, as opposed to, maybe like a visual or cloud to cloud based alignment between stairwells.
Awesome. All righty. Great. And we've also got, let's see, can you kind of briefly share about how you differentiate, materials when you get to the modeling phase, or, systems? I know you've mentioned this is, mentioned photographs. Is that helpful for doing that?
Yeah, so of course, the photographs, are useful on, all the architectural pieces. You have, some nice high quality color imagery. So that's usually not an issue. A little bit more challenging is getting into the above ceiling where it's dark, and you're dealing with essentially a grayscale simulated image from the scanned data. So we usually can tell a little bit of, what is there. Of course, you can identify, ductwork and things, not only just based on the shape, but you'll get some, reflection off of it. So you know what you have there. And then as far as systems are concerned, we typically, when we're in the field, if we have the ability and opportunity, we pop that ceiling tile and climb up that ladder. There's pipes that will have labels on them, especially if it's a newer space. I know in particular that the one area I spoke about earlier, there was a bunch of piping coming through there that was labeled. was able to do some extra scans in that area to help, plan ahead and supplement the back end work.
Awesome. And I've got a question here from Merrick. Merrick, do you have to stop moving the NavVis card at each of those locations? You remember the picture that had all the little gray, the 360 images? Are you stopping the cart there, or do you just keep walking or something?
So we recommend stopping, just so you don't get blurry photos. More advanced users, they learn in the field when you need to stop, where you don't need to. Essentially, if the room is well lit or you're outside, the camera doesn't need as much time to take a photo, just a very short split second. So you can slow down, take a photo, and keep rolling. But if the environment is dark and dim, you want to stop so the photos don't get blurry.
All right. Fantastic. Let's see here if there's anything else popping up from Merrick. Well, this is a good softball for you, Merrick. Can you tell us what SLAM stands for?
Yep. SLAM stands for simultaneous localization and mapping, and this is what's powering up our scanners, that they can build the floor plan and position themselves in the floor plan all while you're scanning the building.
Yeah, and do you to do that, do you need to close the loop, or do you recommend closing the loop on the paths that you take, the trajectories with the scanner?
Yeah, so there's no need to close the loop, even though we recommend closing the loop because each loop closure improves accuracy. If you cannot close the loop and it's a large building and you want it to be as accurate as possible, then we recommend scanning control points that act as essentially nails in the point cloud, tying the data to the survey control.
Gotcha. Yeah, I was going to ask you about survey control next, so I already answered that one for me. Fantastic. All right, let me jump back over here to a question or two for James. How much time did y'all spend doing QA/QC on the automated extraction? Because that's one of those steps that's a little bit different. Because the algorithms are never perfect, and there are always those false positives like doors, and so you do spend some time cleaning those things up. About how much time do you think spent on that?
Yeah, I would say there's a couple of steps where we're going to continue to review that data. Initially, within Edgewise, we're probably looking at maybe 2 to 4 hours, depending on the size, that we extracted there, to extract some additional ones that maybe were missed, clean up those doors, things like that. And then, of course, when we bring all that into Revit, there's going to be another check against the point cloud data, because when you're doing that automated extraction relatively quickly, you may put a wall over a door, or you might just miss it completely. So it's kind of built into the modeling process that already exists, but I would say no more than a half day for those typical small areas, and we probably had, like I said earlier, about 8 of those areas.
Awesome. And I got a question about the wall extraction. Is it automated or semi-automated in Edgewise? And the answer is we released a new version of Edgewise Building, about 5 months ago, that now supports full automated extraction for unstructured data as well as structured data. So you can now do the full automated processing with mobile scan data, which is part of what prompted this webinar. So if you're an Edgewise customer and you haven't used the building product in a while, go take a look. There's a lot of improvements in it. Merrick, I've got another one for you here. Basically, oh shoot, I lost the question. Where did it go? Oh, there it is. Is it necessary to use the ground targets for control points with the NavVis system? And if it's not necessary, what's the difference in accuracy, using those things versus not?
Yep. So it's not necessary to use accuracy, and in smaller projects, using ground control wouldn't improve accuracy much. And smaller projects, I mean floor plates less than 10,000 square feet. We have our own precision SLAM that is very robust. If you're scanning a large building, in mobile mapping, the accuracy is a slightly different thing than in static scanning, because you have local accuracy and global accuracy. For the M6, our accuracy is LOA 30 standard, which means it's anywhere from 1 to 5 millimeters locally and 5 to 15 millimeters globally, meaning across a building, and it could be an airport, shopping mall, a huge building. If you tie in data to survey control, you can preserve local accuracy more throughout the whole space. So you're essentially preserving that local accuracy over the whole building, and you eliminate drift that might occur on a very large project.
Yeah, that's a great way of describing it. I noticed you tied into the US IBD LOA standards there. So anybody on the webinar that's not familiar with the US Institute of Building Documentation, US IBD's got some great helpful documents for understanding scanning accuracy, for specifying it, as well as for modeling accuracy from scan data. So go check out their website if it's new to you, and membership is super cheap. Get access to those resources for very little money from your firm. And then I got another question here. So Merrick, can you also use the SLAM anchors with the new NavVis VLX, or how do you register the VLX cloud? That's maybe a little explanation for people on the call what the VLX is as well that aren't familiar.
Yeah, sure thing. So yeah, definitely VLX is a hot subject right now. It's our brand new wearable scanner. So something between a backpack, something between a handheld, that was released just last week. And one of the new things here is that the new scanner can take floor targets as well as the wall targets, because it's got an IMU. It knows exactly how you tilt it. You can tilt it any way you want and touch it against the wall, against the floor, or anywhere else your control point might be. And anything can act as a control point that you can measure.
Do you have anything maybe you want to show real quick, just for people to kind of see it?
Oh yeah, I'll be more than happy to show a couple of screenshots and maybe some.
All right, yeah. Here, let me make you a presenter real quick. Yeah. Sorry, James, I took it away from you for a minute.
And let me know if you can see it.
And just to be clear, that is not a laser scan?
Yep, that is my hometown that I miss a lot. But yeah, so definitely, great presentation, and the workflows from the M6, which is a very powerful device. VLX is not a killer for the M6. It's more of a complementary tool, because as James was explaining, M6 doesn't fit everywhere in the building because of its size. The VLX, it's a device that is much easier to carry around, much more mobile. You can essentially take it anywhere where you can walk. You can take it off your shoulders, put it up above some pipes, you put it up the ceiling, put it down underneath other pipes around the equipment. So it's essentially like an oversized handheld that happens to be more accurate than the regular handheld would be, and creates much more quality data. So, taking a quick look of how our point clouds look like, we can start with a little 1-minute fly-through video from right outside our headquarters in Munich, Germany. So the building that we see right now, this is where our office is located, and this is where we took one of our new scanners for a spin to see how it captures outside. So you can see it's good enough to scan facades up to probably 6-7 stories. It's still called VLX IMMS, which stands for Indoor Mobile Mapping System. I guess that's the industry jargon. Nobody came out indoor-outdoor mobile mapping system acronym yet. But yeah, it doesn't matter. You can scan inside, you can scan outside.
I think you just coined it IOMMS. So there we go.
It rolls on the tongue, you know.
Oh, this looks really good. I haven't seen this yet. I know you guys have I think you guys are doing a webinar next week or something, or maybe this week with Spar 3D.
Yeah.
I think showing this off, but yeah, this looks really cool.
Yep. So on next week, on the 26th, we have a webinar hosted by Spar 3D, as you said, where our CEO, Felix, and our head of sales, Ben, will be doing official, let's call it, I don't want to say launch, but showing it off to anyone who is interested to see the workflows. How does the scanner look? How does it work? And what type of data it produces? Because, you know, compared to other handhelds on the market, it's definitely, you know, 2020. And when it comes to point quality, you can see a paper towel roll being left on a kitchen table right here in our office there, and, you know, individual plants on the leaf on the right side of your screen. So that we are very proud of the point cloud quality we can achieve with VLX. So anyone who'd like to join the Spar 3D webinar, more than welcome to come.
Cool beans. Well, I'm going to send this back to James here in case any of the other questions pop up, and then we've got. I'll take questions for about 2 or 3 more minutes, and then we'll call it a day. And then yeah, if anybody's got more questions about VLX, you know, reach out to the team at NavViz or hop onto that webinar. Looks like a really nice piece of kit. So James, back to you. What was your, you know, did you guys go and check kind of your total error and also what was your total error goal? And then I think also we've got a bunch of people asking about how did you get above the ceiling tiles, just in terms of registering them and stitching them together within those kind of error expectations or accuracy expectations. Want to take a crack at that?
Yeah, no, that's a good question. So we promised in this case in LOA 20. However, we know that not through this project, but we have run in-house tests to validate levels of accuracy with the mobile system compared to tripod data that was captured. And in particular, when we're using the SLAM, which in this case we utilize those checkerboard targets, we will be able to maintain and achieve the same level of accuracy that we achieved with the scanner. So as long as we've done our job correctly with the tripod scanners, we know that we'll achieve LOA 30, and the maximum error, of course, is going to carry through to the mobile system. So the same as it would if, you know, a surveyor had shot a point, or, you know, you did have an accuracy, you know, out of tolerance, that would carry through. So in this case, we would have achieved that LOA 30 through the use of the SLAM and tightening the accuracy with proper loop closures, which our technicians are always doing regardless. The second question you asked about ceiling tiles. So, you know, with this building, this is typical ceiling height. You know, we were able to use a step ladder, pop the tile off to the side. And we have some simple telescoping tripods that we use. We basically break the plane where the scanner is slightly above the plane of the ceiling tile and slightly below. And then we use the area below to place some spheres or checkerboard targets and use those as our registration points. We also, of course, in some cases, will place spheres up above the tiles, but typically we like to use the areas below because it's easy to leave some spheres behind when you're in a large space and you're putting them up, you know, above the ceiling tile.
And spheres are expensive.
Yes, they are very expensive.
All right. Well, I'm gonna call it a day here. We've got a bunch of other questions that have come in. Certainly don't have time to answer them all. We will try and follow up with people afterwards with answers to those questions. So if you didn't get your question answered, we will do our best to get back to you pretty quickly. And again, please feel free to reach out to any of us. Obviously, contact James at PrecisionPoint if you guys have questions or interested in having them come take a look at a project for you. Any questions about Edgewise or the kind of Scan-to-BIM process, reach out to myself or just the ClearEdge 3D in general. And then on the acquisition side, any questions about the M6 or the VLX or any of the awesome software NavViz has to view that data, like Indoor Viewer, to reach out to Merrick. And with that, thank you all so much for listening and sticking in. And we will get that recording out in about a week or two. And so look for the email to anybody who registered. And if somebody else is interested in getting that recording, tell them they can always go register after the event, and we'll send that recording to them as well. So thank you. And thank you so much, James, for your time putting this together.
Yeah, no, appreciate it. And thanks for inviting me, and we're happy to be here.
All right. Thanks, everybody. Adios.
Thank you, guys. Bye.